Hello, everyone. Welcome to Machine Learning APIs by Example. Did everyone enjoy the concert last night? Awesome. LCD Sound System is a tough act to follow, but I'm going to try my best. I'm going to show you how to access pre-trained machine learning models with a single API call. My name is Sarah Robinson. I'm a developer advocate on the Google Cloud Platform team, and you can find me on Twitter at srobtweets. So to get started at a high level, what is machine learning? Machine learning is teaching computers to recognize patterns in the same way that our brains do. So it's very easy for a child to differentiate between a picture of a cat and a dog, but it's much, much more difficult to teach a computer to do the same thing. So the idea is we train these models, and they improve over time with more and more data and experience. So what we have here is a diagram of a typical deep neural network. And we can think of the input to this network as pixels, and the output is going to be a prediction. And the layers throughout the network are looking for certain features in the image. They're looking for maybe the shape of the ears, the eyes, or the nose. And the output is a prediction, or a classification, as either a cat or a dog. But let's take a step back for a moment. And let's do this without a neural network. Let's do some human-powered image detection. So looking at these two pictures of an apple and an orange, if we were to write an algorithm, what are some features we might look for in our code to be able to differentiate between these two? You can shout it out. Color. Color is a great one. So if we were to look for color, we could look at the majority of the pixels in the image. If the majority of the pixels are red, it's an apple. If they're orange, it's an orange. So that would work great on these two examples. Then what if we have grayscale images? Then we have to start all over again and look for possibly a different feature. What might we look for this time? Texture. I heard texture. So we could look at the texture. That would differentiate between these two. But then what would happen if we got crazy and added a third fruit? If we added a mango? You get the idea. We'd have to start all over again. Now, all these pictures are pretty similar. These fruits are all very circular. So if we instead had two images of things that were completely different, this should be a pretty easy task, right? What if we had a picture of a dog and a mop? And we needed to differentiate between the two. These two things have nothing in common, right? The mop is not living or breathing. It doesn't have eyes, a nose, or a mouth. It's actually kind of difficult. So here we have 4 pictures of sheepdogs and mops. And it's kind of hard, even for the human eye, to tell the difference between the two. So the idea here is we don't want to write specific rules in our code to look for certain things in our pictures. We want to write code that will find these patterns for us. Because we might not have just photos of animals and fruit. We might have photos of everything. And in addition to photos, we might have other types of unstructured data, like video, audio, and text. So what I'm here to talk about today is a suite of tools that Google Cloud Platform offers to help you make sense of this unstructured data through machine learning. On the left-hand side, we have tools to help you build and train your own machine learning models. TensorFlow is an open-source framework, lets you build and train your own models with your own custom data. And Cloud Machine Learning Engine lets you run managed TensorFlow models on Google's managed infrastructure. What I'm going to focus on today is the right-hand side. And this is what I like to call friendly machine learning. These are APIs that give you access to pre-trained machine learning models so that you don't have to worry about building and training your own model. All you need to know how to do is make a REST API request. And as developers, you can focus on building awesome functionality into your applications. So I'm going to give you a tour of each of these 5 APIs. And I'm going to get started with the Vision API. So let's dive right in. The Vision API lets you perform complex image detection with a simple REST request. And before I dive into the specifics of the API, for each section, I want to give you an example of a customer that's using it so that you can get a sense of how it's being used in production. So for the Vision API, my example is Realtor.com. And they are a real estate listing service. And they're using the Vision API in their mobile app. So they have an iOS and Android app. And when people are out and about looking at houses, they can take a picture on the app. And they're using the Vision API's OCR, their optical character recognition, to extract the text from the image of the listing. And then they can pull up the relevant listing inside the application. So let's take a look at some of the core features of the Vision API. The first one we have here all the way on the left is label detection. And label detection can tell us, what is this a picture of? For this picture, it might tell us cheetah, animal, field, etc. Then we have face detection. Face detection can tell us, are there faces in the image? If so, where are they? How many faces are there? And what emotions can we find in the image? Are they happy, sad, angry, or surprised? OCR is the use case that I mentioned on the previous slide with Realtor.com. So this feature can identify text in an image. It can tell you what language that text is in and where the text is located inside the image. Explicit content detection is pretty self-explanatory. This will tell you, is the image appropriate or not? This is actually really useful if you've got a site with a lot of user-generated content, people uploading tons and tons of images. You probably don't want to have somebody sitting there manually classifying each image as appropriate or not. Instead, you can just use an API call to do this. Send the image to the Vision API. It'll tell you if the image is appropriate, and then you only have to manually review a small subset of your images. Then we have landmark detection, which can tell us, is there a common landmark in this photo, and what are the latitude, longitude coordinates of that landmark? And finally, logo detection to tell us, is there a company logo present in the image? So I want to show you what the JSON response from the Vision API looks like for just 2 of these features. The first one is face detection. This is a selfie I took with 2 teammates on a trip to Petra in Jordan last year. And it returns an object for each face found in the image. So this is just the response for my face. So we can see that for my face, it returns headwear likelihood, very unlikely, which is true. I'm not wearing a hat in the image, although my 2 teammates are. And then joy likelihood is very likely. I am smiling in the image. It also gives me a lot more data on where different features are in my face. So I can use that if I want to draw a box around the face in the image or something like that. The next JSON response I want to show you is landmark detection. So everyone knows what this is, right? This is the Eiffel Tower in Paris. It's actually not. I was fooled too, don't worry. It is the Paris Hotel and Casino in Las Vegas. So I wanted to see, could the Vision API spot the difference? And the answer was yes. With 80% confidence, it's able to identify this as the Paris Hotel and Casino in Las Vegas, and we get the latitude, longitude coordinates of that landmark. So in addition to those 6 features that I just touched on, a couple of weeks ago, we added some new features to the Vision API, which I want to highlight on this slide. The first of these is crop hints. This will give you suggested crop dimensions for your photos. The second, which I'm most excited about, is web annotations, which lets you search the internet for more details on your image. And I'm going to dive into that in a little bit more detail on the next slide. And then finally, we have document text annotations, which improves the OCR model. So if you have images with lots of text, like a picture of a receipt or a business card or a resume, the model will do a much better job extracting all of that text from the image. So looking a little more closely into web annotations, I'm a big Harry Potter fan, so I'm going to use this image to show you web annotations. This is a picture of a car. It's not just any car. It's a car from the Harry Potter movies, and it is currently on display in a museum. So I wanted to send this to the web annotations endpoint and see what entities it was able to find in the image. The first one I found is Ford Anglia, which is indeed the correct model of this car. And then it also returned Art Science Museum, which is a museum in Singapore where the car is currently on display. And then finally, it tells us that this picture is indeed from Harry Potter. We get this all just by sending the image to the API. We also get some other things from the web annotations endpoint, one of which is full matching images. So this will tell us all of the URLs across the web where this exact same image exists. So this is useful if you want to do any sort of copyright detection. If you've got users uploading an image and you want to say, OK, has this image already been published on another site? You can use full matching images to get all those URLs. Partial matching images is kind of like a search by image feature. It'll show you all the visually similar images on the internet. And then pages with matching images will give you the URL where all of these images were found. So I encourage you all to try it in the browser with your own images. If you go to cloud.google.com/vision, I'll have the link on the last slide again. Before you start writing any code, you can upload your images directly in the browser and see all of the JSON responses that I just described for your image. Now, I wanted to show you a demo of the Vision API. And because we're at Google I/O, I wanted to incorporate Firebase into my demo. So what I've got here is a web app that's hosted on Firebase hosting. And it lets users upload images. The images are stored in cloud storage for Firebase. And then I'm using the Firebase SDK for cloud functions. So I've got a function listening on this storage bucket. Whenever a new image is added to the bucket, it's going to send that image to the Vision API. This is an entirely serverless application. And the Vision API returns JSON, which makes it really easy for us to just write that response to a Firebase database. And then we can display the result in a web UI. So if we could switch to the demo. Awesome. So this is the web app I've got here. I've got my latest photo. In this case, it's a coffee cup. And then I've got some entities that are returned from the Vision API, the total number of photos I've seen, and then the total number of emotions detected if there was a face in the image. So I'm going to go ahead and add a photo here. I'm going to add this photo of the Golden Gate Bridge. And then while it's uploading, I'm going to show you my Firebase database here. So we can see it was just uploaded to cloud storage. And my function is being called right now. There it goes. My function just wrote the Vision API response back to my Firebase database. And if we look in here, we can examine all the different things that come back from the Vision API, including pages with matching images. We can see the Wikipedia page where this was found, which is actually where I got the image. And then we can see some of the web entities that were returned. And if we go back to our app, we can see that the new picture is reflected in our application. So I've got this app running on my phone. So the next thing I want to do is I'm going to take a selfie with the audience, actually, with all of you. And we're going to see what the Vision API says. OK, so I'm going to upload that. And while that's uploading, let's go on over here to my Firebase database. And should see it uploaded momentarily. Looks like it might not be working. I'm going to give it a shot again. 1 second. Let's try one more time. All right, looks like that didn't quite work. Might be Wi-Fi issues on my phone. But we saw it work one time with the image of the Golden Gate Bridge. And if we go back to our app, we can see that the numbers of entities were reflected to represent the entities that were found in the image. So if we could go back to the slides. So I just wanted to incorporate Firebase in this demo to show you how you can combine the cloud machine learning APIs with Firebase to create awesome web or mobile applications. Definitely encourage you to check out these Firebase APIs that I used. And going back to our sheepdog versus mop example, in case you were wondering, how did the Vision API perform on these images? So if we look at the response for that dog photo all the way on the right, we can see that the Vision API was 99% confident that this was a photo of a dog. And it's even 77% confident that it's a Commodore, which is the exact breed of dog that it is. Skipping ahead to our mop photos, it was 70% confident that this was a broom or a tool. And I'm going to skip ahead and show you the response for all of them. So overall, this pre-trained model did pretty well on these images that are even pretty hard for the human eye to discern. So on the dog photos, it got 3 out of 4. The third one there, it didn't return the label dog. It said fur, so I wasn't sure if that one was a hit or a miss. And then in the third row in the bottom, it didn't return the label mop or broom for the third one. It returned textile. But overall, this model was pre-trained. It wasn't trained specifically to identify the difference between dog and mop photos, but it did a very good job doing so. And for each API, I want to show you how easy it is to call the API. I'm going to show you these examples in Node, but we have Google Cloud client libraries. You can choose the library in your favorite language to call the API. I'm going to use Node, because that's my language of choice. So here I'm requiring the Google Cloud Node module. And then on my Vision object, I'm just calling it detect. I'm passing it my image file, and then it returns the annotations. I tell it what types of feature detection I want to run. I can also pass it the URL to a file stored in Google Cloud Storage. So we talked about images. The next thing I want to talk about is speech. So how many of you have used the OK Google functionality on your phone? Looks like most of you. So what the Speech API does is it lets developers integrate that functionality into their own applications. Lets you do speech-to-text transcription in over 80 languages. An app that's using it is Azar, and they're a chat application that is connected over 15 billion matches. And they're using the Speech API anytime somebody sends an audio snippet to someone else in a chat. And there's a lot of potential use cases where you may want to combine different cloud machine learning APIs. In this case, they're using the Speech API in combination with the Translation API. So whenever the two people don't speak the same language, they'll transcribe the audio with the Speech API, and then they'll translate it into the other person's host language with the Translation API. So the best way to see how the Speech API works is through a demo. And first, I want to explain what we're going to do in the demo. So we're going to make a recording using SOX, which is a command line utility for audio. And then we're going to create our API request in a JSON file and send the JSON request to the speech API, and then we will receive the JSON response. So if we could switch over to the demo. Looks like we got that here. So I'm going to call my bash script, and it's going to ask me to record a 5-second audio file. So I'm going to record something right now. I built a demo of the speech API using socks at Google I/O. So I'm going to send that to the speech API, and we can see here what my JSON request looks like. We tell it our encoding type. We can see that it did pretty well. It didn't get the word built. Maybe it's a sound system in here. I demoed the demo of the speech API using socks at Google I/O. But it did get Google I/O correct. But notice that it incorrectly transcribed the word socks, which makes sense, because socks is a proper noun. That's the command line tool I used to transcribe the audio. And that's where this speech context parameter comes into play. So you can, if you have any sort of proper nouns that are specific to your application that the API might not otherwise recognize, right? Like I wouldn't normally expect it to recognize the proper noun socks. You can pass it these phrases as hints. So if I hop on over here to Sublime, I'm actually going to add socks to that phrases suggestion. And I'm going to run the same thing again. I'm going to make the same recording. I built a demo of the speech API using socks at Google I/O. And we can see it's now looking for that word in my text, and I'm going to send it to the speech API. Did pretty well. Again, it might be the sound in here. But it did get the proper noun. Thank you. You never know with live demos. So again, just to reiterate, I added this speech context parameter so that it was able to identify correctly this proper noun that I wanted to say in my text. So if we could go back to the slides. If we go back to the slides. Awesome. So in this demo, I used a complete audio file. So I use it in batch mode. But it also works in streaming mode. So if you want to send it a continuous stream of audio, you can send it a stream of audio, and it'll return transcriptions as that audio is coming in. So that is the speech API. Once you're done transcribing your text, you may want to do more analysis on your text. One more thing I want to talk about is how you can call the speech API from Node. So here I've required the Google Cloud module. And I just need to tell it the encoding type, in this case linear 16, and then the sample rate in hertz. And then I call speech.recognize, passing it my local file. Again, I can also pass it a file stored in Google Cloud Storage. So as I mentioned before, you might want to do something more with your text once you've transcribed it. You might want to analyze it. And that's where the natural language API comes into play. The natural language API lets you extract entities, sentiment, and syntax from your text. A customer that's using the API is a company called Wootrick, and they are a customer feedback platform. And what they enable all of their users to do is gather feedback from their app's users as they're going throughout their application. So you may have seen something like that box in the top right when you're on a website or an app. It asks you, how did you feel about this experience on a scale of 0 to 10? So it's pretty easy for them to parse those numbered scores, but Wootrick's job is to help their customers make sense of all of this open-ended feedback. And it's that open-ended text feedback that's much more difficult for them to make sense of, and that's where the natural language API comes into play. They're actually using all the methods of the natural language API. So they're using sentiment analysis to say, OK, did the numbered score that the person gave line up with the open-ended feedback that they sent? And then they're also using entity and syntax annotation to pull out the key subjects and terms from the feedback, and then if necessary, route those to the right person in near real time to respond to the feedback. So let's say there was a customer who wrote in and was really angry about usability in this application. They could route that to the right person to make sure they got a response right away, rather than having to manually review each piece of open-ended text. So I want to dive into each method of the natural language API, starting with entity analysis. So I've got this sentence, and I sent it to the entity extraction endpoint of the natural language API. And it returned all of these as entities in my text. And I wanted to show you the JSON response for some of these entities. So we can see that for each entity, we get the name of the entity, in this case, Google, the type of the entity, organization, and then we get back some metadata. So you'll notice this MID This is an ID that maps to Google's knowledge graph. And if you want to get more information about the entity, you can call Google's knowledge graph API, passing it this ID. And we also get the Wikipedia URL for this particular entity. We can see it correctly identifies I/O as an event. And then we can see the response for some of the other entities here. And what you'll notice is that my name is here is still returned as an entity, even though I don't have a Wikipedia page yet. So if you have entities in your text that might not have associated metadata, the API will still be able to extract those as key terms and give you a response. It'll just have an empty metadata object. So that is entity analysis. The next thing that the API lets you do is analyze the sentiment of your text. So if we had this restaurant review, the food at that restaurant had no taste, I will not be going back. If I worked at this restaurant, I'd probably want to flag this review and potentially follow up with this customer to see why they didn't like it. But it's likely that I would have lots and lots of reviews, and I probably wouldn't want to read each one manually. I might want to flag the most positive and most negative ones, and then respond just to those. So we get 2 numbers back from the natural language API to help us do this. The first thing we get back is score, which will tell us on a scale from -1 to 1, how positive or negative is this text. In this example, we get -0.8, which is almost fully negative. And then we get magnitude, which tells us, regardless of being positive or negative, how strong is the sentiment in this text. And this is a range from 0 to infinity, and it's normalized based on the length of the text. So we get a pretty small number here, 0.8, because this is just a small piece of text. So that's sentiment analysis. And the final thing we can do with the natural language API is analyze syntax. And this is going to give us a lot more linguistic details about the piece of text. So here we have the sentence, the natural language API helps us understand text. And what I'm going to show you here is a visualization of all the JSON we get back. So the first thing we get back is what we call a dependency parse tree. And this tells us which words in the sentence depend on each other. What word depends on this word. Then we get the parse label, which will tell us what is the role of each word in the sentence. So helps is the root verb in this case. API and us are nominal subjects. And then we get the part of speech, which will tell us is this a noun, a verb, or an adjective. And we get the lemma. The lemma is the canonical form of the word. So in this case, we only get one for helps. The canonical form of helps is help. This is useful if you're counting maybe how many times a specific word or term is being used to describe your product. You probably don't want to count helps and help as 2 different things. You probably want to use the lemma form to get the canonical form of the word. And then finally, we get some additional morphology details on the text. So is it first, second, or third person? Is it plural or singular? And these are going to vary based on the language of the text that you send the natural language API. So I want to show you a demo of the natural language API. And how this demo works is I am using the Twitter streaming API to stream tweets related to Google I/O using a couple of the search terms that you see here: Google I/O, Firebase Cloud, TensorFlow, and machine learning. I'm sending the text of these tweets to the natural language API, and I'm using the sentiment and syntax annotation methods. I'm writing that JSON response to the Firebase database, and I'm using the Firebase database to only store the most recent tweets so that I can display a dashboard of them. And then I'm writing all of my tweets to BigQuery, which is Google Cloud's big data as a service tool. It lets you easily query lots and lots of data. So I've got 2 separate processes running for that. So if we could switch to the demo, I'm going to go ahead and start up my Node server. And I'm going to go over here. And what we see here is we have the latest tweets displaying. We should see some start streaming soon. I'm not displaying the full text of the tweets because this is a public event, so what could go wrong with displaying tweets on a giant screen? And we've got the nouns, verbs, and adjectives in each tweet. There we go. We got some new ones. And it's displaying the sentiment of the latest tweets. So it goes from -1 to 1, how positive or negative is this tweet. And then we can see, make this a little bit bigger, we can see the sentiment by hashtag, and we can also see the most common adjectives that are being used in the latest tweets. So that's pretty cool. But the other thing I did was I am sending all of my tweets to BigQuery for some historical analysis. So if I open up the BigQuery web UI here, we use SQL to write queries in BigQuery. we can see all of the tweets that I've collected since I started streaming this, which is a couple of days ago. So I've collected in total over 54,000 tweets. And this is what my data looks like in BigQuery. I can visualize it and write queries directly in the browser. So this is what each row in my table looks like. I've got the ID of the tweet, the text of the tweet, the timestamp of when it was created, the number of followers the user has, the hashtags, which is returned from the Twitter API, and then I have this giant JSON string of all the syntax annotation data that was returned from the natural language API. You might be wondering, how am I going to parse that using SQL? Well, BigQuery has a feature called user-defined functions, which lets you write custom JavaScript functions that can be run on rows in your table. So I've written a function here. I want to count all the adjectives that have been used in all these tweets that I've streamed. So this is going to be run over that syntax annotation JSON string. It's going to parse that JSON string and count all of the adjectives in all of my tweets so far. So I'm going to go ahead and run this. Keep in mind, it's running this custom function on all 54,000 plus rows in my table. And we can see it finished in just under 8 seconds. And if we look down here, we can see the most common adjectives that are being used to describe Google I/O and machine learning. And one other thing I wanted to show you. Thank you. One other thing I wanted to show you is this is the Natural Language API products page. And you can all go here. I'll share the link at the end. And try out the Natural Language API on your own text. And I wanted to show you a feature that we added to the API just 2 weeks ago. And this is entity-based sentiment. So within a sentence, this will give you the sentiment of specific entities in your text. So if I have a sentence like, I really liked the sushi, but the service was terrible, I'm going to send this to the API. And we can see that sushi got a score of 0.8. Service got a score of negative 0.9. And that's really useful, because if I had sent this sentence to the API and got a sentiment analysis response for the whole sentence, it probably wouldn't be too useful to me. What I really wanted to know is what this person liked about specific entities in my sentence. So we can go back to the slides. So with this demo, I just wanted to show you how you can combine Firebase, again, with Google Cloud Platform, using Firebase to create a real-time dashboard of my latest tweet data, and then BigQuery so that I can do a historical analysis once I'm done gathering the data on all the data I've received so far. Another thing that you might want to do with your text, just forgot the code snippet here. So if you want to call the natural language API from Node.js, here's a snippet of code of how you would do that. In this example, I am passing it a file from Google Cloud Storage. You can also pass it raw text. And just call language.annotate, and it'll give you your annotation response back. So next thing you might want to do with your text, once you're done analyzing it, is you might want to translate it into many different languages. You likely have users for your application all over the world. You want to make sure your app is accessible to them wherever they are. With the translation API, you can translate your text in over 100 languages. Before I get into that, I wanted to talk a bit about Google Translate. How many of you have used Google Translate before? Looks like almost all hands went up. I rely on it a bunch when I travel. Last year, I was on a trip to Japan, and I was at a restaurant where almost nobody spoke English, and I really wanted to order octopus. So I got out my handy-dandy Google Translate app, typed in the word for octopus, and found out that it was taco. I was a little confused, but I decided to roll with it, ordered my taco, and I was able to get this delicious octopus as a result. So Google Translate is very handy for more things than just translating the word octopus. And with the translation API, you can integrate the functionality of Google Translate into your own applications. And one company that's doing that is Airbnb. What you might not know about Airbnb is that 60% of their bookings are between people that use the application in different languages. They're using the translation API not only to translate the listings, but also to translate the reviews and conversations. And they found that using the translation API has significantly improved a guest's likelihood to book. Here's a snippet of code of how you would call the translation API from Node.js. And notice here that I'm only passing the string I want to translate along with the language that I want to translate it to. I actually don't need to tell it the source language of the text. So another thing you can do with the translation API is if you just want to detect the language of the text that a user is typing in, you can use the API for that as well. So I pass it my text and the language I want to translate it to, and I get the translation back. Recently, we made some improvements to the underlying model behind the translation API. And this new version is called neural machine translation. You'll just notice a difference in the quality of the translations as you send your text through the translation API. So the first model of translation that we used, called first generation translation, the way that worked is it translated each word in the sentence, word for word. So this might be similar to how you would translate something if you were traveling, had a dictionary with you, and you wanted to look up a sentence. You might translate each word, word for word, and the result would probably be pretty accurate, but you might miss some of the linguistic nuances of that text. And what neural machine translation does is it takes each word and looks at it in the context of other words in the sentence, and it's able to produce a much more accurate translation. There's a great New York Times article about it. I've got a bit.ly link right there if you're interested in learning more about how neural machine translation works under the hood. And just to show you what the improvements look like, I know there's a lot of text on this slide. I'll explain it. As I mentioned, I'm a big Harry Potter fan. And so what we have all the way on the left is a paragraph from the original Spanish version of Harry Potter. And obviously, Harry Potter was not translated via an API. It's been translated in over 70 languages. And they actually had somebody that spoke each language in charge of writing the translated version. So this is from the original translated version. And then in the middle column, we see what first generation translation produced when I translated it to English. On the right-hand side, we see what neural machine translation produced. And I've just bolded some of the differences. So we can see that the verb made was changed to manufactured, which is much more specific to the context of this sentence. And we can see if we skip to the bottom, fence of the gardens changed to garden fence. So lots of improvements with neural machine translation. The final API I want to talk about today is the Video Intelligence API. And this is the newest addition to our suite of cloud machine learning APIs. And what the API lets you do is understand your video's entities at shot, frame, and video level. A company that's using this is Cantemo. They are a media asset management company. And all of their customers have lots and lots of video content. So they upload their content to Cantemo's platform. Cantemo helps them transcode it, edit it. And what they're doing with the video API is they're enabling their customers to make their video content searchable so they can search within their videos. The best way to see the video API is through a demo. So if we could switch back to the demo. What I've got here is a Super Bowl commercial for Google Home from this past Super Bowl. And I'm going to play just the first few seconds of this. So what we can see here is a lot of scene changes happening in this video. I'm going to stop it here, but we can see that it started with a mountain pass, switched to a house, then a street scene, then we saw a dog and a garage. So if we were to manually transcribe this video, we'd have to watch what was happening in every scene and write down those tags and store them in a database somewhere. What we get with the Video Intelligence API is we get some data at a high level, what is this video about? And then at a more granular level, what is happening in every scene? So if we look down here, we can see a visualization of the JSON response we get back from the Video Intelligence API. So it tells us that there's a dog here. And not only does it know there's a dog in this video, it tells us exactly which scene the dog appears. If we skip to the end, we can see a birthday cake. And then if we scroll down, we can see a couple of other labels that were returned. So not only did it know it was a dog, it knows exactly what type of dog it is. And if we scroll down a little more, we notice that it identifies that mountain pass from the opening scene. So this is what the API can do with one video. But if you're analyzing videos, it's likely that you have lots and lots of video content. So you could be a media company that has hundreds of petabytes of videos sitting in storage buckets. And one common thing you might want to do is create a highlight reel. You might want to look for a specific entity and pull that out across your entire video library. And with the JSON data we get back from the Video Intelligence API, it makes this really easy to do. So if I go here, I've got quite a few videos in my library. And let's say I'm a sports media company. So I have lots and lots of sports footage. I only want to find the scenes relevant to baseball. Oops, go back here. I'm going to search for baseball. And we can see that, boom, the API tells us immediately which videos have baseball in them. And not only does it tell us which videos have baseball, it tells us exactly where in those videos baseball appears. So we can see in this video there's lots of baseball scenes. But this one is my favorite example because there's only one tiny 1-second clip of baseball in this video. This is the year in search video that Google publishes at the end of every year, highlighting top searches from throughout the year. So if we were to look through this manually, we'd have to watch the entire video, just for this one scene. With the video API, we can skip directly to that scene. And that's from last year's World Series when the Cubs won. And we might have even missed that scene if we were manually reviewing the video. So I'm going to do one more search. Since we're at Google I/O, I'm going to search for Android. I'm going to find all the Android phones in my videos. And we can see that I'm jumping here, and I can see exactly all the places where Android phones appear in my video, which is pretty cool. So with the Video Intelligence API, what used to take hours now takes minutes, and it's easy to search a large library of video content. If we could go back to the slides. Thank you. Wanted to share a little bit of how that demo works under the hood. All of the video content is stored in a Google Cloud Storage bucket. And I've got a Cloud function listening on that bucket. So whenever a new video is added, that Cloud function is going to send the video to the Video Intelligence API. And one of the request parameters that I get with the Video API is it lets me pass it a file URL of a Google Cloud Storage file where I want to write my JSON response. So when it's done annotating the video, I write that response to a separate Google Cloud Storage bucket. And the front end of this application is a Node.js app running on Google App Engine. So the front end of the app doesn't actually call the Video API directly. It simply references the videos from one cloud storage bucket and then gets the associated metadata from another cloud storage bucket. Here's what the JSON response looks like for label detection. So we can see in this video there's a scene with a bird's eye view. It tells us what the label is, bird's eye view. We get the start and end time of this label in microseconds. And if this label appeared in more than one scene, there'd be multiple segment objects there. And we also get a confidence score. It's 96% confident that it's identified this correctly. Here's another one from the same video of a portrait label. We also get the start and end time for this label. And here's some code of how you would call the Video API from Node.js. The Video API is currently in private beta. So that's all I've got today. That concludes my presentation. I really encourage you all to start using the ML APIs, and you can try them all directly in the browser. So if you go to the browser, I only showed you the natural language API demo in the browser, but all of the APIs have a browser demo where you can add your own data before you start writing any code and see all of the API responses visualized directly right there. I've got the code for some of the demos you saw in this talk in my personal GitHub. ML Talk Demos has the code for most of the demos. I haven't yet added the Firebase ones, but I hope to do that soon. And then the Video API demo app code is in a separate repo on my personal GitHub under Video Intelligence Demo. So I encourage you all to try them out and get started. And thank you for coming.